Welcome back to Calculus 1. We're working on problem number 8 from part 2 of homework number 4. This is module 0.2.5. The solution is 2 minus x. So let's go ahead and see how we get that value. In this problem, we're asked to find the distance between the number 2, so we'll call that x1, and the number x again. But here in this problem, unlike problem number 7, we're told the initial condition that x is less than 2. So if you think about a number line, here that means that we have the value 2, and somewhere over here on the line is the number x. So here are our two numbers. Now how do we find the distance between them? Well, for example, let's just, before we work through the algebra, let's just pick an x value. Let's pretend that x was something that's less than 2. Let's say 1. Well, then we would take the absolute value of 2 minus 1, which would equal 1. Absolute value of 1 is equal to 1. Now, if we switch the order, we would have 1 minus 2, which isn't a problem because we'd have the absolute value of negative 1, which is still 1. So they both come out to be 1. Let's pick another number out here. Let's say we picked x to be equal to negative 5. Now, clearly the distance here is 7. Let's check it out. Well, that would be 2 minus negative 5, which is the absolute value of 2 plus 5, which is 7. The other way would be the absolute value of negative 5 minus 2, which is the absolute value of negative 7, which is also 7. So again, it works. Here's where the confusion comes. We only have a variable now. We don't actually have a number. We just have x. So when we compute the distance, we would say, okay, well, we've got the two numbers. We've got x and 2, and we put those inside the absolute value. Now the question is, can we just drop the absolute value signs? And the answer is no. Here's where we have to be careful. If this guy on the inside is positive, positive means that you can drop. So you can drop the absolute value signs, or sign, okay. If it's negative, we can't just drop the absolute value sign. We need to make the inside piece, this guy inside here, we need to make it the opposite of what it is. And so what we do is we multiply by negative 1. Okay, that's the trick. So let's go back here and look at this. We've got the absolute value of x minus 2. Now we knew originally that x was less than 2. So if x is less than 2, then x minus 2 must be less than 0 if I subtract 2 from both sides. And since x minus 2 is less than 0, that means that it's negative. So this guy inside is actually negative. Now think about it. When we plugged in any of our x values, when we did x, here's our x values, x minus 2, we always came up with a negative value on the inside. And what do we have to do? We had to use the opposite of that value. So this is going to be the opposite of whatever guy is inside. And so that'll end up being minus x plus 2, and you can write that as 2 minus x since addition is commutative. Okay, now, if you write it the other way, it's not a problem. So if we write it as 2 minus x, again, since x is less than 2, that implies if I subtract x from both sides, I get this. So 2 minus x is a positive number. So this is just equal to 2 minus x. So here and here, I get the same answer regardless of which way I do it. I just have to be careful to make sure that that inside is not negative. And if it is negative, then of course we go ahead and we multiply the inside part by a -1.